Welcome to Module 2 on Gravitation. In this module, we will be covering Kepler's laws of planetary motion and the Cavendish Experiment for determining the value of g. Kepler's law of planetary motion was formulated after Johannes Kepler's detailed study of astronomical data. He discovered that planets move in elliptical paths, not perfect circles, around the Sun. Kepler's first law, the law of ellipses, states that the path of planets around the Sun is elliptical, with the Sun at one focus. The second law, the law of equal areas, states that an imaginary line from the Sun's center to the planet's center sweeps out equal areas in equal time intervals. This means a planet moves faster when closer to the Sun. Kepler's third law, the law of harmonies, states that the ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distances from the Sun. Now let's look at the Cavendish experiment for g value. The apparatus consists of a light, rigid rod with two small lead spheres, suspended by a thin wire. This is called Cavendish's torsion balance. The principle relies on the tension in the twisted wire, which exerts a restorative force proportional to the angle of rotation, pushing the system back toward its original position. In the procedure, two large spheres were brought near the small ones, causing a gravitational attraction that twisted the rod. By balancing the torsional force and gravitational force, Cavendish calculated as 6.75 by 10 to the power of -11 Newton-meter squared per kilogram squared, close to today's accepted value. In the next module, we will learn about free fall, the feather coin experiment, acceleration due to gravity, escape velocity, orbital velocity, equations of motion for freely falling bodies, and the difference between mass versus weight.